Now I have used a predefined setup for the FRF. Now I like to show you in Dewesoft 7.1 we have a nice function where we do generate the displays out of your channel setup. A very nice feature, very useful for the FRF function. So let's see how to do that. So now I start from scratch. That means I really go and say, okay, so stop and make a new setup. New setup, nothing. So what I need to do now is I want to do an FRF. So you say, okay, we know there are two channels. So we say the first channel is acceleration. And then the channel number 2 or channel number 1 is response. So that's it. And now, of course, I'm a measurement guy. I immediately say, okay, let's see if that works. So what I do is I go to my scope and say, oh, let's see if I hit that. Can I see something? You know, also the other thing is, oh, the color is not so good. So I change maybe the one the red and then the other the blue or something like this. Okay, and show this in my scope. So now there are the two channels. The scope people, they know exactly, don't use free run, use norm mode, set the trigger level somehow and hit the line. Okay, now you see two channels, excitation response. What's important here is the trigger level. So I remember the trigger level, something like 100, or it could be a little bit higher, something like this. Yeah, so 100 to 200, something like this is okay. This I remember. And now I go back to my channel setup and go to model test. So blank model test, how to do the setup? Very easy. You say, now I want to do triggered FRF. Trigger level, you remember, maybe 150, something like this. And then you say, I have 1, 2, 3, 4 times 4 points for the excitation, and that means also I want to do a roving hammer. I want to move the hammer from 1, 2, 3, 4, and then I just assign them. This is my excitation. These are all my excitation channels, right? And then the response channel is already here, and then I also say, okay, this is, I moved my sensor not on point 1 and moved it on point 2, so I can say this sensor is at point 2. And then maybe give me a couple more lines, maybe 2048 lines. That's it. Okay, this is my home trigger setup. And now the next step is if I go to measure and I go to the model test, you will see this sign, and it shows here immediately that I already have a prepared setup. Also now you see either this setup is prepared for the dark background, so it is quite wise if I say I change the setup. For that I have to stop that. I change my global setup and change my display now to a dark blue background and go back to my measure again. It just looks now much nicer for you to see. So now I could start immediately with my measurement, you see? So this is my first excitation channel. So you see here this response channel. Also the predefined setup gives you the response and also the phase here. And here also you see the coherence and of course the frequency range you see up to 2500. In this case, you know, for this mechanical engineering stuff what we do, 500 Hz is more than enough. The 5000, of course, all of you know, come from the sampling rate, because we are running 10 kilo sample, so we have nyquist half 5 kilohertz bandwidth, so that means I changed it to that. So that's fine. Now you might wonder, where is my nice graph here and my geometry? If you also want to show the geometry, maybe I add on the geometry for you. You see here is the, if you click on here, is the editor for the geometry. So we have 4 points. I just, okay, I add on 4 points and I say, okay, I want to have probably in the X, no, I use the Y axis. So we have 1, 2, 3, 4 points. So these are the 4 points here you see already. Now it would be nice if you have lines between them. If you want lines, you say trace the lines and you say I want to add a couple of these lines. So the first one should go from 1 to 2, okay, you see it here. Then the next one from 2 to 3. And then, oh, we need one more from 3 to 4. Done. Save, exit. Here we are, right? You like it?
Wow.
Very easy. So this would be now I continue my measurement. I made the first step, make my next measurement. 1, 2. And I'm still a right-handed man. Next point. 1, 2. And the next point. Okay, so this is basically, you see, from scratch done. But now maybe you want a couple other things I show you here. Where is my circle fit? You wonder? Okay, let's make the circle fit. You see the model test is still this mark here. That means so far nothing I changed. If I go now to the design mode and I change one of these pictures, then this disappears and now I add on, for example, my circle fit. So this is my circle fit window, where I can go to a certain area and I have to switch off this and show you now at this point the precise frequency, if it's possible to recognize that. The circle fit is really, you know, we have a line frequency resolution, then based on the sampling rate and the record length and the block size, and now with the circle fit between the lines we calculate the peak, and therefore we get to the higher resolution here. So this one thing. One other thing also I often like here to add on maybe a scope to show you a little bit, let's say, the excitation. So you know what I did before. So when you hit the hammer, you could see, is this hit okay or not? So this would be, you can add on. But the nice function you can see here is the basic FRF, the difficult things with these buttons, all this stuff, is all done automatically. You may modify it if you want. Your customer will like that for sure.